Good morning. In this lecture series, we see about crank sliding link cylinder. We see about what is the meaning of crank slider link and how is it working in this principle, this way. Okay, so let's move on to introduction. The what is meaning of crank? A crank is an arm attached at a right angle to a rotational shaft by which is reciprocating motions is imparted to or received from a shaft. It is used to convert a circular motion into reciprocating motion or reciprocating motion is converted into circular motions. The arm may be a bent portions of the shaft or separation of the arm or disc attached to it. These are types of to attach the shaft. The shaft is rotating the wheel drum into reciprocal direction, which is reciprocal motion can be produced by a crank. The crank cylinder is moving to the direction either it up or down, exactly which is happens in a crank sliding link cylinder mechanism. The functions working of this crank and slide mechanism, the attached to the end of the crank by a pivot is a rod usually called as a connecting rod. The end of the rod attached to the crank moving in a circular motion, while the other end is usually constrained to moving in a linear sliding motions. The functions working almost the reciprocating engine used to crank, which is connecting rods to transform the back and forth motions of the piston into rotary motions. The crank or the incorporated to the crankshaft. What is the purpose of the crank slide link? The cylinder mechanism is used to in the reciprocating motions of the vehicle, which is causes into the movement of the piston inside the cylinder, which is compressed after a fuel intake the procedure combustion, for example, petrol engine. So, for example, we take as an example of these crank and slide mechanisms. So, we constructing the petrol engines that is called as the four-stroke engines. There are four-stroke means the first stroke we are introducing in a fuel intake. The second one we introducing in a combustion. The third one we are introducing in a power chamber. Then fourth one is a exhaust. Exhaust the output gas. So these are the process coming undergoing the working principle of petrol engine. The first one is a fuel is intake, the crank moving in the downward direction. After the downward direction, the power exhaust stroke will be generating. That is, the piston is moving in upward. After compression stroke, the power will be generating in the inside of the fuel. That is, the volume is decreased so that the power can be increased so that automatically the piston comes is down in downwards. So after the piston is coming downwards, the exhaust gas will be exit from the exhaust valves. These are the working principle of the petrol engine. So how it is calculations? The displacement of the end of the connecting rod is approximately the proportional to the cosine the angle of the rotation of the crank. When it's a measured from the top at its center, we denote as a TDC. So the reciprocating motion is created as steadily rotate crank and the connecting rod is approximately simple harmonic motions. So after that, by using of the cosine law, we calculate the distance that is x is equal to r cos alpha plus L, where x is the distance of the end of the connecting rod from the crank axial. The L is the length of the connecting rod, R is the length of the crank, and alpha the angle of the crank measured from the dot center. Technically, the reciprocating motions of the connecting rod the, departs from the sinusoidal motions due to the changing the angle connecting rod during the cycle and these expressions that is equal to x is equal to r cos alpha plus the square root of L square minus r square sine square alpha. This difference becomes the significant in a high speed engines. The mechanical advantage of the crank, the ratio between the force on the connecting rod and the torque on the shaft varies throughout the crank cycle. This relation between the two approximately tau is equal to F sine alpha, where tau is called as a torque, F is called as the force of the connecting rod, but in reality, the torque is maximum at the crank angle less than the alpha equal to 90 degree from the TDC for the given force on the piston. One way to calculate this angle to find out When the connecting rod small in the piston, the speed becomes the fast in downward directions. So the given is steady crank rotational velocity.